Hi friends, welcome back to our channel. Today we are going to discuss about the continuation of the different layers in the eNodeB logs. So as you can see, different layers are there as usual from the eNodeB logs aspects. So today we are going to discuss about only the PDCP layer. Okay, so now I'm trying to filter out the PDCP logs here. This is the whole set of logs which contains all the logs. As you can see, other logs are there. Now I'm just going to give the PDCP for understanding the PDCP layer. Okay, so I'll give find all in current. So now you can see, basically to just give an overview about the PDCP, it talks about the various encryption mechanism and also mainly related to encryption and decryption. It takes care about the security aspects and also the sequence number maintenance. Multiple functionalities are there from the PDCP, so you can check it out, the PDCP layer design course, in order to understand much more in detail related to the PDCP aspects. Okay, but in today's video we will try to dig further related to the PDCP. Again, I'll just repeat one of the scenario, the eNodeB logs what I have collected. Example, this call is actually about the L3 call initiation from the UV side, and once the UV is successful with the L3 call and also the data traffic, it is going into idle mode. Again, once the idle mode, it went to the idle mode, then a paging is triggered, and for that it is again initiating the RRC connection request. I think in the previous videos we have seen related to RRC analysis where the OTA messages contains the message exchange actually related to either paging or normal L3 call over the air messages. Okay, so now today we'll discuss about how the PDCP will behave against that particular the L3 call, whatever the scenario I have just explained. Okay, so now you can see again I'm taking the RRC. So there is no difference actually, because we can see we can take only the timestamp and then we can try to map it where the PDCP comes into the picture. Okay, now you can see example in the RRC. Okay, let's say RRC connection request, RRC connection setup I will take. So this is the timestamp. So I'll go to the eNodeB log, control enter, find next. So this is the RRC. Now the corresponding PDCP also is there here, right? So this PDCP we can see SRV radio bearer 1, which means this is coming for the RRC connection request, right? SRV1, it comes in the SRV1. PDCP and RLC job is to satisfy the SRV1 or DRV1 or DRV0, whatever, all the signaling radio and the data radio bearers. Then the PDCP and RLC will take care. For that, the RRC will do the configuration. So here we will try to see PDCP sequence number bits 5, length bytes, reordering window, maximum sequence number 31, right? Which means it is a 5-bit sequence number. That's why 0 to 31. Right? Status report required or not, SRV. Okay, now we will try to see what is currently happening right from until. We'll take one particular range of timestamp this time and we'll try to analyze. Example, I am taking this one, right? RRC connection request, which is 538.658. So I'm taking here 538.658 and another one until the next RRC message, example here, right? Okay, so this is the one. So this is RRC connection request, right? And this is RRC connection setup. In between these two, what is the situation with respect to the PDCP? This is what we are going to analyze now. Okay, now I am taking all this PDCP copy into the new page. Okay, so that we can have all the logs captured related to the PDCP. Okay, now you can see. Okay, so the timestamp I am just going to, but this you won't get it in the PDCP because this is taken from the eNodeB log. So I am going to the log, and in between this one 758, this you will get it in the this log. Okay, Now this is the SRB1, correct, and later this is 714. So before our 714 we have to look 539 714. This is the milliseconds. This is the millisecond level, right? 539 714. So in between, this is the one, sequence number 109. It is hitting at sequence number 109 and 86 bytes. TX and RX encryption, TX and RX encryption for this DRV1. It is trying to get it. Oh, 758. Sorry, I think 758. This is the one. Sorry, I was mistaken. So, yeah. So this is one aspect actually, and the other one you can see the next RRC level document, RRC level thing. So DL info transfer, UL info transfer, which is 096. So 579 096, correct. I'll just remove this 579 096. Then the other one, is 600 534. 600 534. These are the two timestamps. I'm just trying to go have a look at here, right, so that I can find it. So this is SRB1 PDU DL info transfer. We got it, right? And the PDCP 599 714, correct. Encryption none, decryption none, and sequence number 0. So in order to fulfill this, how many sequence numbers are there, right? So you can see PDCP sequence number 0, right? Only one sequence number. So there are no other sequence numbers here. PDCP sequence number 1, right? So or else we can search here also PDCP sequence number SN1 with respect to that particular timestamp. With respect to that particular timestamp, this is the timestamp. So this is a timestamp. We can continually go in that SRV1, sequence number 1, sequence number 2, right? Sequence number 3, sequence number 4, sequence number 5, sequence number 6 until here. So 6 sequence numbers are required for the DL info transfer and UL info transfer, right? So this is how we can analyze the PDCP. The main important thing here we have to understand here is sequence number tracing TX and RX with respect to TX with respect to RX. So maybe we can see somewhere RX also would have given. Let's try to see example here in the window. So instead of TX, I'll keep RX. RX is not there actually. I think somewhere we are missing. Oh, RX, it is already here. Sorry. This is the one we have to search actually instead of that. RX sequence number, right? So you can see RX sequence numbers also in order to understand better. I'm just taking top again for searching the RXs. These are all RX sequence numbers. So again it is going up to 1074. This means it is more than 10 bits, which is 12-bit sequence number. That's why we are getting RX. Okay. So overall, this is also handling with respect to the SRB1 and also DRB1, right? All the DRB1s it is handling. So only one bearer with respect to that, how the PDCP is actually behaving, right? Default bearer basically. All the things you can see. All are decoding properly. There is no retransmission that you can expect here in this particular case. It is very well actually working, and you can try to analyze always this particular timestamp. According to timestamps only you can able to get the things better. Okay. Okay, fine. Yeah. So that's all from the PDCP perspective. Maybe in the next video we will try to see the other configurations. Some of the physical layer configurations we'll try to see, and and then we will see related to MAC aspects later on. Thank you, and see you again in the next video.